So why we use the repeaters in transmission media? First one, a repeater is an electronic device, right? And then which functions only on the physical layer of the OSA model. So it is used in the OSA model of physical layer, right? So it is a electronic device. It is a electronic device. And the next thing, the signals here, the corresponding signals that carry the information within a network can travel a fixed distance, right? It should be in the fixed distance before attenuation or any other the integrity of the data. So attenuation means that is kind of noise, right? So the corresponding signal that carry the information within the network with a short period. So a repeater is receives the signal. The repeater's work is receive the corresponding signal before it becomes too weak or corrupted. This is the job of or role of the repeaters. So again I repeat, a repeater receives a signal. Signals from source. So signals from source, it receives the signal, and before it becomes too weak, before it becomes, that is very important, before it becomes too weak or corrupted. And the next work is here, the regenerate the original bit pattern. The regenerate the original bit pattern. And the next one, the repeaters then sends the refreshed signal to the destination. So what is the job of this repeater? It is regenerate the signal. Why it is regenerated? If the signals are too weak or corrupted. If some problem is occur, automatically it's regenerate the corresponding signal and send it to the destination. This is the ultimate aim of this repeater. And also a repeater can extend the physical length of the LAN. Extend the physical length of the LAN. Yeah, it's extend because the repeaters is used to connect within the certain distance, right? So this is a intro of the repeaters. Now you understand this is an electronic device and it's is used in the physical layer. Then the signals automatically, this is a process, signal that carry the information within the network. So the repeater's work is the repeaters receives the signal and before it becomes too weak or corrupted. Before it becomes too weak or corrupted. If it is too weak or corrupted, automatically it's regenerate the original bit pattern, regenerate the signal and send it to the refreshed signal to the destination, right? So this is a intro of the repeaters. Okay, here see this diagram. So you can understand this is a OSI layer. This is a destination side OSI layer. So the corresponding repeater is attached with the physical layer, the first bottom of the layer in the OSI model. So here it's a it is attached. It is attached. So see this original source device. This is a end device of destination. It is attached in the segment, not in the LAN. So it is attached in the segment with the additional component or additional hardware of this connection. So within the certain distance, the repeaters is receive the corresponding this segment one signal. If it is corrupted or if it is too weak, it automatically regenerate the corresponding signal and resend to or refreshed signal send to the segment 2 or the destination. And one more thing, a repeater does not actually connected to LANs. It's not connected to LANs. It's connected the two segment of the same LAN. That means it's a mediator. It's like a mediator. So this is a repeater job, right? And next one, the segments are connected still part of one of the signal LAN. Okay, that is also connected with the LAN. Okay, then extend the maximum cable. So how long it is extend? What is the length of this extension? It's depend upon the repeater, the category of the repeater. So the first category of the repeaters here, that is a Ethernet 10 base 5. This is a Ethernet 10 base 5. So the maximum segment length is 500 meter with 4 repeaters or the 5 segment. That is the main thing. So here the base 5 is a maximum segment length is 500 meter, right? And also is used to extend the cable to 2500 meter. You can extend the corresponding cable to 2500 meter when you are using in the Ethernet of 10. That is a 10 base 5. If you are using the Ethernet 10 base 2 means what will happen? The maximum segment length of 185 meter with the 4 repeaters. This extension level is 925 meters. It is a second category. It's nothing but that is a second category of the repeater. So the Ethernet and the base 10. See, this is a two types of the repeaters is here. Two types of the repeaters is here. So the first one, 10 base 5. The maximum length is 500 meter, and we can extend the corresponding LAN cable up to 2500 meter. So the second category of the base 2, based on the situation, based on the need, we can choose the Ethernet repeaters, right? Base 2 means the maximum length is only 185. If I need the small distance meet, I can use the base 2, 185 meter. And the 4 repeaters, the cable extension level is 925 meter, right? So this is a repeater categories. Okay. Next, so this is a function of the repeater. Already I told the function of the repeaters means it is regenerate the data. See the first diagram here, the right to left transmission, the corresponding signal, the corrupted signal. It is a source. It is a source. It is a repeater. The corresponding corrupted signal is passed. When it is reached to the repeater, it automatically regenerates the missed parts or the missed patterns here. Is a missed patterns, corrupted signals are enter into the repeaters and transmit to the signal. Right? So this is a function of the repeater. Here, this is a function of the repeater. Then what happened in the left to right transmission? It's the same work, the same job. Or the corrupted signal or the weak signal is regenerated with the equal pattern. That is a normal pattern of the repeaters. That is the main thing. So the corrupted signal, when it is enter into the repeater, it automatically regenerated. Why we need regenerated? Because to avoid the loss of data. So this is a function of the repeater. Sir, the same function is work for the amplifiers. Amplifiers is also doing the same job, right? It's just boost of the signal and equalize the corresponding or loss of the signal, loss of power or loss of gain, like that. So what is the difference between the repeaters and the amplifiers? Because both are same. Both are attached with the LAN connection, and it's boost up the signal and also send the corresponding original signal to the destination. So what is the difference? Why we need the repeaters in the transmission media? So before that, I just give the note for corresponding signal. The repeaters forward the every frame here. The repeaters forward the every frame that has no filtering. That has no filtering. No filtering capacity. Yes, of course, because the repeaters cannot filter any kind of the signals. Any kind of the signal. That is a very important note. And here the repeaters is a regenerator. Repeaters is a regenerator, not an amplifier. So it is a regenerated method. Yes, corresponding regenerated method. So now you can understand it's not an amplifier. So the repeaters and the amplifiers is not equal. Now see here the next one. Yeah, this is a diagrammatic representation of the repeaters and the amplifier. So what will happen? So when the corresponding, this is a loss of signal. See, this is a loss of signal or corrupted signal or weak signal. So whatever it is. So the same kind of signal, when it is reached to the repeater, when it is reached to the amplifier, what will happen? So when it is reached to or pass over with the repeaters, it automatically regenerates the signal with the equal frequency. Just regenerated the corresponding original signal, or the bit pattern will be created. But in the amplifier here, the corrupted or the weak signal will boost up with some other frequency. So what happen in the amplifier, they may be occur with a noise or the amplified signal or attenuation. So these are the problem will occur when you are boost up the corresponding original signal, right? Isn't it? So what happened? You have to rectify that problem by using the SNR, the noise rate, and so these are the maximum level. So what happened? You have to reduce the noise first. You have to reduce the noise first. Then you have to reduce the attenuation or any other the extra signal. Then only you can receive. Then only you can receive. Then only you can receive the exact signal. Then only you can receive the exact signal. Okay, so this is the main reason. This is the main reason for that. And the next one, and here, so this is the main difference of repeaters and the amplifier. Now you can understand. You no need to or regenerate or any classification method for this regenerated signal, but all the noise reduction, additional impairments will occur in the amplifier. There is a no impairment. It's a equal signal. So only the repeater sees best performance compared with the amplifier. Okay. So okay, now the repeaters and the amplifiers difference. So the repeaters is used for regenerating the original signal, right? Regenerate the original signal with the help of received pattern and retransformating and the regenerated signal. The repeaters is used for regenerating the original signal, with the help of our received signal pattern. So what is received? It's automatically regenerated and sent to the original pattern. But in the amplifier side, the amplifiers amplify means boost up the signal by increasing the amplitude. So that time only the problem, the noise and the attenuation, that problem will occur, right? So the amplifier amplifies the signal by increasing its amplitude. Second point here, the repeaters removes the signal noise while regenerating the signal bit by bit. That is a very one of the advantage using the repeaters. It's automatically reduce the noise, whatever it is from source. It's automatically reduce the noise while it's regenerated. So no need to reduce the noise again while it's receive the destination. So the repeaters removes the noise while it's regenerating the signal bit by bit. But in the amplifier side, as an amplifier cannot differentiate between the intended signal or noise, whatever it is, it's automatically boost up the signal whenever it is too weak or whatever it is, it's automatically increase, either including with the noise. So that is a job of amplifier. And the next thing, the repeaters has high gain power. Here high gain power and low output power. So it receives the high gain power. It's highly signal is or a variant of the signal. It automatically neutralizes the corresponding signal. This is the meaning for that. It's automatically neutralize the signal. So the repeaters has high gain power and low output power. High gain power and low output power. And also amplifiers have low gain power and high output power. Yes, because it's input of the very low signal or weak signal to the amplifier. After it's boost up, it's automatically increase the signal level. That is a job of amplifiers have low gain power and high output power. Okay. The next point here, the repeaters are used in the stationary environment. Here, it is a user-friendly of environment while it's a radio frequency signal is stable because it's a equivalent bit pattern of the signal, such as building like that. But in the amplifiers are used in the mobile environment. Amplifiers are used in the mobile environment because we can boost up any kind of the connection is there. So where the radio signal is weak and consistently changing, for example, the remote access, it automatically reduces, right? So this is another point of used in the amplifiers. Then the next one, repeaters increases the signal to noise. Repeaters increases the signal to noise ratio, right? So it's reduced the corresponding noise ratio while it's decreased the error associated with the signal. That is one of the one of the advantage of using the repeaters. So the repeaters increases the signal to noise or a noise ratio which decreases the errors associated with the signal. Then the next in the amplifier side here, the implication of the amplifier's result is minimized. The result is minimized, but the noise ratio is increased because it's just to boost up the connection, right? Signal. So it's happened. Then the next thing, the repeaters no one hand in the middle of the transmission line. Yeah, it's a other hand in the middle of the transmission line, but most of the amplifiers are present in the near end points. Yeah, this is also one of the important point. Because already I told it's connected with the middle end. Middle end means every 50 meters or every 100 meters you can fix the corresponding repeaters. But the amplifiers maximum it's fixed in the rear end or the near end of the end point or the destination point. So what happened? It's receives the corresponding connection, and boost up the signal and transmit to the destination. This only happen when you are using the amplifier, right? So next one, yeah. So is a difference between amplifier and signal. Again, I will explain with some of the distance based here. See, before that, I just want to show one video about the repeaters. See this video. But again, I restart that. Okay. Yeah, why and what, why, how the corresponding repeaters function. So see, this is the baseline. So what happened in this three device? I'm going to. This is the first left hand side. This is a source. Then the final end. This is the rear end, and the final. This is a destination. So what happened when I'm send the signal through this medium? So the distance between this is the distance is 185 meter. So what kind of the Ethernet repeaters will be used? The base 2. Base 2 is enough because the corresponding distance is 185 meters only. Okay. So I used the base 2. What happened in the base 2 time? That is a destination. The round is a destination. This is a source. So I'm going to send the signal from the source to destination. The initial thing here, yeah. So okay, so the first system, the first device, end device is a node. The first node is a 0.1. This is a PC1. So the signal is passed through this PC1 through the transmission medium. So this red color R is a strong signal. It's indicate the strong signal. Again, the green color is a very light signal, and dark. The black is also very light. The yellow color denoted is a too weak signal to reach the destination. So the red color is a strong signal, and the yellow color is a weak signal. So when I send the corresponding signal to this medium, I use the repeaters. What happened? I send the same signal through this medium, but in the middle of the transmission, I use the repeater. So what happened? It is regenerated. It is a distance of 50 meter. We can fix this is a 50-meter distance of the repeaters. So if I send the signal, what happened when it is reached? It's reached the corresponding the repeaters. Automatically, the weak signal is converted into the strong signal. The weak signal, when it is reached to the repeaters, it's automatically convert into the strong signal and send it to the destination. So the new strong signal will be sent to the destination. So this is a working principle of the repeaters. So this is a working principle of the repeaters, right? So this is an example. Okay, sir. In this same example, if you are using the amplifiers, then what will happen? See the next one. See, this is an example for the corresponding source and destination, right? So the source and the destination, So I'm going to send the frequency of or the signal from source to destination, the R1, R2, R3, R4. So these are the repeaters. R1, R2, R3, R4, these are the repeaters. So the repeaters means here within the period of distance, 50 meter, 50 meter, 50 meter. So I'm fix some kind of the repeaters is here. What happened if I send the high frequency? So this is a starting point. So the high frequency, when it is reached the first repeater, it will be reduced with the normal level. And when it is reached the second repeater, it is also reduced. The noise will be reduced. And when it is reached the third repeater, it's automatically again it is reduced. In the final repeater, completely remove the noise and send the exact signal to the destination. Right? So this is a main difference of send the repeaters. And one more thing, you can so here, yeah. So this is the same kind of signal will be sent to from source to destination. From source to destination. So what happened? So what happened here? The corresponding destination will be sent. The corresponding destination will be sent. Yes. See here, this is an amplifier source to destination. The high frequency, this is a high frequency. If I send the high frequency means the same high frequency will be reached to the end of the amplifier, because the amplifier is attached in the near end of the destination. So till this distance of the amplifier, the same signal with the noise, the same signal will pass through the with the noise. What happened in the amplifier? It's again increased. The corresponding signal will increased and sent it to the destination. Okay, sir. If the source is sent with the weak signal, means the same weak signal will reach to the amplifier. Again, it's gain the power of the signal and reach to the destination. Then we have to apply the SNR rate to reduce the noise and convert the original signal. So this is an extra problem when you are using the amplifier. But compare with the repeaters, no need to apply any extra calculation to reduce the noise, because it's automatically reduced. When the repeaters is reached, it automatically reduce the noise and send it to the another repeaters. Right? So this is a major difference between the repeaters and the amplifiers. So you have to understand about the repeaters and the amplifier method, right?